Welcome to qnawire.
In this question, we have to calculate what is the value of the energy given the values of T, L, and U0. So in order to do that, we begin by solving this equation for the energy. By doing that, we get the following. T is equals to E to minus 2 times G times L. We can invert by taking the logarithm, so we get the logarithm of T is equals to minus 2 times G times L. Then we can see that G is equals to minus the logarithm of the transmission coefficient divided by 2 times L. Now we have to use the equation for G, which is this one. By plugging in this equation here, we get the following. The square root of 2m u0 minus e divided by h bar is equals to minus the logarithm of t divided by 2 times L. Now we have to solve for the energy. So we send the h bar to the other side to get the square root of 2m u0 minus e is equals to minus the logarithm of t times h bar divided by 2 times L. Now we square both sides to get 2m u0 minus e is equals to the logarithm squared of t h bar squared divided by 4 times L squared. Then we divide everything by 2 times m, so we get u0 minus e is equals to the logarithm of t squared h bar squared divided by 8 times m times L squared. And finally, we send e to one side and these terms to the other side. So we get an expression for the energy, which is the following. The energy is equals to u0 minus the logarithm of t squared times h bar squared divided by 8 times m times L squared. Now, all we have to do is plug in the values that were given in the problem and evaluate the final answer. By doing that, we get the following. E is equals to U0, which is 18 electron volts. In order to convert from electron volts to joules, we would have to multiply it by the electron charge, but electron volts is fine for this question. So we have 18 minus the logarithm of t squared, so the logarithm of 0.01 squared times h bar squared, which is 1.055 times 10 to minus 34, and this is squared, and this is all divided by 8 times m, which is 9.11 times 10 to minus 31 times L squared. L is equals to 0.55 times 10 to minus 9. 10 to minus 9 is because of the nano prefix on the meters, and this is squared. Note the following. The second term, this one, is also an energy, but this term we will evaluate to an energy that is measured in joules. And here we have an energy that is measured in electron volts. So we convert this term from joules to electron volts by dividing it by the electron charge, which is equals to 1.6 times 10 to minus 19. And then we get our final answer, which is the following. The energy of that electron is approximately 17 electron volts.